What is going on, guys? My name is Hussein, and in this video I want to talk about what happened on May 30th, 2020 that caused many services such as roku, Stripe payment, LGTVs all of a sudden just stop working, and all of that because of an event that happened, essentially specifically a root certificate that is called AddTrust External Root certificate that expired at that day. And you know what is the worst thing, guys? Is that none of that should have happened even if that certificate is expired. And I'm going to explain why. Most of the reason is because of a software bug. And that's why I'm talking about it in this channel, because we're a software channel. If you're interested, stay tuned. So guys, I talked about certificates in this channel. I talked about TLS in this channel. I talk about all this stuff. Check out the content in this channel to understand more. But briefly, if I have a client here, a browser or a C# app that want to talk to a web server that is hosting an HTTP protocol, and specifically HTTPS, so it uses TLS, right? How does the server identify itself so that the client can actually trust it? One way is to present it with a certificate, right? And this is to prevent man-in-the-middle attacks from faking requests, right? Because that's the only way to prevent man-in-the-middle attacks, right? We need for the server to actually provide a certificate that is being signed by someone else. Usually it's called a certificate authority, that this certificate, this says, okay, this is valid. And the client, once it finds this certificate from the server, it starts validating that certificate. And what does that mean? It basically takes the public key of the certificate authority and tries to encrypt the content that is sent and then compares it against the content of the certificate being sent by the server, right? And if it matches, good. That means that content has not been tampered with. I trust HusseinNasser.com. I trust Google.com, right? And what happened here is you take the certificate authority, which is a third party that signed this thing, okay? Example is Let's Encrypt, DigiSign, and many others, right? However, how do you trust Let's Encrypt itself? Let's Encrypt is a certificate authority. It's called intermediate. And Let's Encrypt is an intermediate certificate authority that has a certificate by your own. How do you trust it? Same thing. The client is responsible of going up the chain. So, okay, who issued the certificate for Let's Encrypt? Or who issued the certificate for DigiSign? You go and validate that. And how do you do that? You take the parent public key of the certificate, who issued the Let's Encrypt certificate, and you verified it, and you do the same thing. And then you take that parent and you go up and chain until you reach what is called the root certificate, which is trusted by just everybody. And this is it doesn't have a parent, right? So, and it is self-signed. Almost all root certificates, not almost, always, all root certificate that are at the top are self-signed. And you would say, okay, if they are self-signed, how do we trust them? Well, they are trusted by means of physical trust. So it means Microsoft or Mac OS, or Firefox install those root certificate on your operating systems. Things like AddTrust, things like DST root CA X3, right? You can go into any certificate, click on the padlock and go up at the stack until you reach a root certificate. So there are many root certificates on the planet, okay, guys? And it's just not one. And here's the bug, what happened on May 30th, okay? The client who validate those certificates, you need a library to validate, right? You can write it your own, but who does that these days, right? You have to rely on some sort of a library that validates that. The browsers have a library that basically validates, right? And openSSL is a very popular library that validates. And how does it do? It goes up the stack like that. It just goes up all the way until it finds the root certificate, and that's it. It stops like that. It assumes linear. And that's the bug. That's the problem. And Ryan Sleevey here, and I'm quoting his tweets. I'm going to reference his tweet thread. Go check it out. But essentially, that's what happened. OpenSSL assumed there is always going to be a linear up into the root. But that's not the case. There are many certificates that uses mesh. They don't rely on one single root certificate. That would be disaster, right? You have to go up and essentially funnel and find other root certificates that are valid. And that was the bug. When AddTrust, whatever it's called, AddTrust External CA expired, right? Despite that root expired, there are other root certificates that are still valid. But since the OpenSSL just goes one route and finds that it expires, it throws an error. And if it throws an error, you cannot establish a TLS connection. And when you cannot establish a TLS connection, what happened? You disconnect the TCP connection. And when you disconnect the TCP connection, you cannot send any requests, right? And that's where everything falls apart. And that was the bug. That small bug of validation caused all this panic. And here's what happens next, which is even worse, in my opinion. People have been checking in thousands of commits to disable verification altogether. Oh my God. People are freaking out because, hey, people are yelling, customers are yelling. What do we do? Disable verification. And when you disable verification, what does that mean? That client just do verify equal false. You can do it on any application. You can just add that check, which is the most dangerous thing you can ever do. But we don't have a choice. People need to work until they upgrade their OpenSSL to the latest version. I'm gonna reference the correct version. I don't know which versions are actually fixes that. But the worst thing you can do, guys, is to disable verification, because now what? If I carried out a man-in-the-middle attack, right? I can sniff everything, right? Because you're not going to verify that. You're not going to verify my certificate. If I somehow intercepted your request, your TLS handshake client, hello, I'm going to respond back with a server certificate that is mine, and I'm going to pretend to be the server for you. And I can even decrypt. I'm going to just pretend to be a TLS termination and then connect to the backend, and just I can completely blindside that and pretend to be the server, and that's very dangerous, obviously, guys. Obviously, carrying a man-in-the-middle attack is not as easy these days, but still possible, right? All right, guys, that's just a quick video. I'm going to reference the diagrams that you can see them here. I'm going to reference all the resources that just read about that. But it was a very interesting story to follow, right? And if you're running into this, follow Ryan Sleevey. He has some recommendation of what to do and what library to actually pick up in order to upgrade that thing, and then make sure you have the correct version of OpenSSL. And he's also recommending another library that I forgot what it's called to verify your TLS certificates and other stuff, guys. Quick video today, and I'm gonna see you in the next one. You guys stay awesome. Goodbye.